Welcome to EDU World Space.
So we're told that an automobile has a wheelbase of 3 meters, so that's the distance between the tires is 3 meters here. We're also told that the center of mass is 1.2 meters from the front tire, so in here. And we want to figure out how much weight does each tire support of the total weight of the vehicle, which is 1,500 kilograms. So we know that I'm guessing because there's two front and rear tires here, so we have 2F. This would be the force on one of the front tires and one of the rear tires. So we have 2FF, and again, if we look at it from this direction, the vehicle, the tires are here, and we're assuming that the center of mass is right at the center of the vehicle, so that these two tires carry the same weight. So we know that 2F sub F, or the front force, times 2F sub plus 2F sub R has to be equal to mg, or the force on one front tire plus the force on one rear tire has to be half the weight. We can also take moments about this point here, so that mg doesn't come in. So this is the center of mass, and since it's static, we could take moments about any of these points. If it were dynamic, we'd be forced to take moments about the center of mass, or change our the sum of the moments wouldn't equal the rotational inertia, the time of the rotational inertia. But that would be later to come in your studies. So what we have here is let's say, we know that FR, or 2FR, times this distance, which is d1 minus d2, must equal 2ff times d2. And so I canceled out, there's a 2 in here that I canceled out. And so we have this equation. So we have two equations and two unknowns, and we can plug in numbers, and we find that that the total force on the front two tires is 8,830 newtons, and the total force on the rear two tires is 5,890 newtons. The force on the one front tire is 4,410 newtons, and the force on one rear tire is 2,940 newtons.